So we had a question regarding the string of discrete time steps within AnyLogic, and I thought that this might be a good opportunity to reflect a little bit more broadly on the issue of discrete and continuous time and the consequences for model logic. What you heard in over lunch was some comments on conversion of the model, originally written in NetLogo to AnyLogic. And one characteristic of NetLogo that it shares with some other frameworks, including notably Recast, is that it is specifically situated in discrete time. What do I mean by discrete time? You'll find actually lecture slides from me for this from me in lectures online, where I comment over this a little bit more detail. But what I mean is that in discrete time, we have time divided up into a set of delineated steps, each of which occurs some fixed distance apart in some more theoretical continuous time. But the model goes in lockstep from step to step to step to step. Okay? And things happen at the steps. So maybe these steps are in the level of 1 month in real time, maybe they're at the level of 1 year, maybe at the level of 1 day. But we have a series of steps that take place, and in each step there's a set of accounting that goes on for actions that need to occur conceptually that may have occurred since the last time step, and they all sort of take place at the time of the step. So maybe people are determined whether or not they die or not. It's determined whether or not someone advances in their education or changes their income. Perhaps we determine whether someone contracts a disease, etc. And those things occur at these fixed sort of boundaries, these fixed points. All agents are updated at those times with respect to those attributes. So, for example, some number of agents may die, some number of agents may contract some disease or progress in terms of stages of disease, etc. on each of these concepts. That's what I mean by discrete time. Okay? If there is some underlying notion of sort of a timeline that's aside from that, you might speak of each step as being, again, month or day or year or whatever. This is very common. If you look back historically at the literature on agent-based models, this has been the dominant form. Some of the oldest work from von Neumann in the mid-1900s on cellular automata models, models with patches and sort of situated agents that are located attached. You'll find them progressing these discrete time steps. Very natural model, it's sort of simple model to think about. Now, a set of additional packages since that point have elected to support what I'll call discrete events of continuous time. So there's events that occur, but they occur at a continuous timeline. So we have a similar timeline, but in this alternative model, events occur however frequently they need to in eventually quick succession. By no means are assumed to be sort of fixed in their spacing. You may have bursts of events associated with some little outbreak, and then long periods of stasis. I introduced this notion before, and I argued that this is in a continuous time here, and these events are discrete events. There's a specific thing to be handled at that point to which we need to respond. So for example, AnyLogic adheres to this as the default model of time. You'll also find other packages such as ModGen, which is a package used in Canada by StatsCan and increasingly by other agencies for the so-called Cohen model, the population health and economics model. So some salient trade-offs between these approaches. I'll note that AnyLogic does support both approaches. By default, you're given the freedom to have this latter approach, which can be used to simulate the former. You could have, how would you have in continuous time, given the primitives you've learned, the sort of constructs or elements that you've learned to add to your models, how would you simulate the first of these within AnyLogic? Just knowing what you know right now. Can anyone say? What could you do if you wanted to make certain things happen at specifically spaced ticks? How could you do that? Okay. And how would you get the model to kind of wake up at that interval and do something? You could set up an event. You could also do it incidentally. As for a lot of things in AnyLogic, you can do it quite a few different ways. A lot of different ways. In many cases, an arbitrarily large number of different ways. So you could set up a state chart where you have an internal transition that fires at a certain timeout after a certain timeout. But the point is, you could simulate this using events here. And on those regular ticks, once a month or once a year, you could actually handle everything that's handled here. However, this use of discrete events in continuous time was not an accident. This was chosen to allow this as the default, to support this mechanism of events in continuous time was elected for a certain reason. And there's a couple reasons that are frequently motivations for this. I can't say what was foremost in the minds of our colleagues in St. Petersburg, but there's a couple advantages that are conferred by this. One thing is you can capture these sort of punctuated equilibria, these things that occur in very different time scales. You can capture in great detail events that need to play out really quickly, and then back off when there's very little going on. When there's little action that needs to take place, you can leap and jump forward in time by big steps. When things are happening a lot, you got to really attend to the detail of what's going on and choreographing things. Then you go forward little bits of time at a time as needed to handle each successive event. So that's one reason. You want to be able to capture multi-scale effects or effects that exist at sort of bursty scenarios or multi-scale way. That's one reason. But there's another reason too. And this is based on my experience working. I mean, if you look chronologically, I spent most of my time doing agent-based modeling with a discrete step context. In repasts, in a project known as SimBuilder, did some work in FDML, did some work in types of environments for cellular automata that are no longer extant. But here we are going in discrete time. And one of the awkward things about a discrete time formulation that really becomes a challenge in the context of health is dealing with competing risks. What I mean by this is, consider someone in the course of a year. They may have many events which go on in the year. They have some risk of mortality. They have some changes to their income. They have changes to their health state with respect to cancer, changes with their health state with respect to kidney disease, changes with their health state with respect to several different comorbidities. These may all seem straightforward, but the point is some of them actually interact, some censor others. So for example, death. If death occurs, and at the same year you think someone's going to develop a cancer, really you're talking about potentially death censoring the emergence of cancer if it occurs before the cancer, in which case the cancer shouldn't be recorded as part of the registry because the death would have occurred prior to it. If you're dealing with things at these boundaries only, it becomes challenging to broker among these different competing risks. Say someone graduates and someone relocates. Well, did they relocate before they graduate? If so, it might have censored the graduation and eliminated the possibility of graduation, for example. Were they fired before they received a raise? Well, it turns out that often we end up calculating probabilities of a lot of things occurring within this past year, and then we've got to figure out sort of which has higher precedence than the other. And sometimes it turns out our model results can be, in non-obvious ways, dependent on the particulars, the vagaries of which order we handle these events in. In other words, we handle death before we handle progression of disease, before we handle, designation with educational status. And sometimes there's non-obvious ordering difficulties between these things. So some packages provide you a way of randomizing the ordering of those events, but generally this interaction between the multiple types of events is something that is a troublesome worry often in these contexts. If you have events occurring at their natural time, so graduation occurs when graduation does during the year, you have death occurring sort of at any time during the year, you have progression with respect to these conditions that might be diagnosed in a population registry occurring at the natural times. Then if death occurs first, the other events are descheduled and it occurs first. You don't have to worry about it as a model builder that these interact. Just whatever occurs first happens, and often that will end up precluding other events from happening just by the nature of the model, but you don't have to really worry about this. So one of the issues that comes up when you have discrete events is there's a lot of action taking place at staged points. And so you've got to be very careful with that. Nonetheless, it's a very useful model, particularly for certain types of situations. And I'd like to show you how AnyLogic does support this. We've mentioned one way that you can support it in the context of particular imposing events, say in main, that will wake you up at particular instances. However, there's additional ways. So to sort of examine this, I'd like you to go to any model where you have environment present. In fact, I'm sorry, just to illustrate better, I'm not doing it justice. Let's go to example models, and we're going to actually go find a model which actually uses these capabilities to their benefit. So I'd like you to go find a model that's called Conway's Game of Life. I'm going to have to find that here. Is it Games and Fun? Is that there? It is. It's under Games and Fun. Okay, maybe it's good we're doing this in the last session of the afternoon here. So or of the week. So here's Game of Life. It's under Examples, Games and Fun. It's called Game of Life. How many people have seen this Game of Life before? Conway's Game of Life, named after British mathematician Simon Conway. So there was a time, ladies and gentlemen, I was a young man, and probably my TH wasn't even born, and at that time it was said that more computational effort had been put into playing this game, and I don't mean human time, I mean computational time, than any other purpose in the world. This is what's called a cellular automata, and it depicts a stylized two-dimensional space where you have very, very simple rules governing the progression of individuals, of cells in this world. So every space on here is divided into cells. You could see a cell can either be occupied, that is red, or not occupied, that's pink, and there's some simple rules for evolution of the cells. As I recall, if you have, if you're empty, so it's a dead cell, and you have exactly 3 neighbors, then you come to life. If, on the other hand, you're an already live cell, there's stringent conditions under which your fate will be determined. If there's 2 or more neighbors, then excuse me, if there's fewer than 2 neighbors, you'll die. If there's 2 or more neighbors, but less than or equal to 3, so between 2 and 3, you'll continue to exist. If it's 3 or more, you'll die. Okay. here we have this model, so each cell is either alive or dead. It's in one of two states, and you can evolve it. And in fact, this model here, if you click, you can actually seed new cells, and for the most part, they die of loneliness if you just seed them in the sort of great hinterlands. But if you click them next to other things, you can make things evolve. Now, this game, yes, this game exhibits a set of known patterns. These are traffic lights, and there's gliders, and there's starships, and you can actually implement computers in this, which are computationally universal. So anything that can be simulated on your machines that you're using right now, including AnyLogic, can principally be implemented in the game of life, because you can set up AND gates and OR gates and build processors in the game of life, and all sorts of good things like that. And people have studied the evolution of organisms in this game, etc. But what my point here is to not regale you with intriguing tales of things that you can build within this game, but instead to show you, if you go to the main object here, and you go to the environment, what sort of environment do you think this uses? What sort of spatial layout, ladies and gentlemen, do you think this uses? It is, what sort of layouts are there? Remember we saw random, for example, as a spatial layout? What's another spatial layout? What's one we might use to depict local connectivity in a network? A ring lattice? What's another spatial layout? Called arranged. And it's arranged in a regular grid. So if you go to the environment, you'll find, for example, that these cells are agents, and they are arranged in a regular grid here. Let's go down here. You say layout type arranged, and that allows them to be placed into this sort of regular environment. But the other thing I want to note is that we have here a situation where we enable steps. Okay, so this gets to Dawood's question: how do you enable this discrete time, this sort of updating at fixed lockstep points here? Well, you have this enable steps mechanism. So what this enable steps mechanism allows you to do is to say there will be discrete steps with some amount of time between them within this model. Now, each cell here, if you go look at the cell, we have a set of properties here, but it's in the agent properties here. Yes, you'll notice that there's handlers for different events here, specifically on before step and on step. And the basic action, I have a lecture on this you can go listen to on my spatial embedding lecture. What you have here is a distinction between steps themselves and event just before steps, which gathers the requisite information to perform the step in a way that won't depend on the vagaries of who is updated before who. So what happens here is there's an event occurring, this step, on a regular basis. Here I think it's every time on unit it's occurring. And just before that occurs, there's a phase where each agent gathers up information that will be needed to determine their fate in the actual step. They gather up the information that will determine what they'll be doing in the actual step. And this decouples the updating of agents. In other words, all the agents gather the information they're going to need based on the current state of those around them. So they have all the information they're going to need to know whether they're going to live or die. And then there's the actual step which occurs, where they just perform an action. They either die or live. And here there's actually, and this is rather terse JavaScript, basically that updates whether they're alive or not based on the current liveness status and the number around them. So they're only alive in the case that they're currently alive, and they're not overcrowded, and they're not lonely. Or if they're not alive and the number around them is 3, then they become alive. There's things that's cut off there. The point is, they gather all the information to do the work, and then they all update each other themselves simultaneously. you do this so that a given agent isn't affected by pre-existing updates of agents around them. If you mix these two together, if you have them gathering the information, how many around me are alive during the actual step? If the ones around you had updated already, then you're not updating based on the situation, when the step began. You're updating based on something that's already changed based on the step. So here you gather all the information and then you perform the update. This, ladies and gentlemen, is the type of confusion, the type of complexity that comes in when you go in these discrete time steps. But there is that capacity to do this. So in short, ladies and gentlemen, AnyLogic can make use on a per environment basis of discrete time steps, and specifically it is enabled with this in the general tab of the environment under enabled steps. And then you can have agents evolve according to these as specified by the agent properties of the appropriate agent class by using on before step or on step, or in the main class you also have corresponding properties of on step. Excuse me, it's in the environment. You have corresponding properties of on before step and on after step. So that's how you can support regular spacing of discrete events within AnyLogic. Does that make sense? Okay. And you'll find other models within this. For example, the Schelling segregation model is another good one, which is provided within AnyLogic as an example model, which uses discrete steps. Okay? Yeah. So that's a great question.